Okay, I think we'll get started now. We still have some people trickling in, but let's go ahead and dive in. Um, what we're going to talk about today is understanding time stepping in GoldSim. This was actually a talk that I gave at our user conference last fall, for any of those of you who were there, and we're going to walk through it again right now. We've got a pretty big group here online, so I don't think we'll do questions during the webinar. At the end of the webinar, I'll unmute people, and if you want to ask a question, then we can do that. But the group is a bit big right now to have questions during the webinar. So I'm gonna cover all of the time stepping options in GoldSim. We'll start out with some very simple things, stuff that is pretty basic that most of you are probably already familiar with, but it really doesn't hurt to walk through it again and kind of remind people some of the basics of how to select an appropriate time step, whether or not to use elapsed time or calendar time. And then we'll move on to some of the more advanced features of time stepping, some of which might just confuse people. They might be kind of new and they may not be aware of them, and some of them which are quite powerful, but probably most of you don't use. We'll cover all of the advanced time stepping features here that could come in handy. But let's start out by just talking about real basic stuff, which is really appropriate not just to GoldSim, but to any simulation tool. How do we select the appropriate time step? Well, whenever you're using a time stepping tool, a simulation tool, the key thing that we have to understand is that the variables that we're simulating are assumed to be constant over a time step. So that's very important. That's what we mean by time stepping. The flow rates or inflow rates, outflow rates, they're assumed to be constant over a time step. That's what we mean by a time stepping model. In most simulation models, what we're really specifying truly are rates. They're flow rates. There might be growth rates if you're modeling a population in a financial model. They might be spending rates. But typically, the key parameters that we're calculating and specifying are rates. And what a simulation model does, it's not the only thing it does, but a primary thing it does, it integrates those rates. So if we integrate a flow rate, we get a volume, right? If we integrate a growth rate, we get the number of people or number of items. If we integrate spending rates or revenue rates, we get the amount of money. So that's basically what we're doing, and these rates are assumed to be constant over a time step. So that's a really key thing that we need to understand. It's pretty obvious, but some people kind of overlook that. That's what we mean by a time stepping model. When I use the term time step and I'll do that throughout this talk, and then we do the same thing in the documentation, but it's really kind of an incorrect term. A time step really refers to a length of time, 1 day, 1 month. What we're really talking about are updates. When do we update the model? We update the model every day. We update the model every month. We update the model every hour. And we often use these two terms in the documentation kind of interchangeably, but the more accurate description of what we're talking about is an update. We're updating the model at a particular point in time. So let's just come back to this thing about how you select a time step. I just want to show a very, very simple example so you can see the impact of a time step on a model. So imagine we're just adding inflow into a pond. So we have a constant inflow and let's say a leakage rate that's proportional to the amount of water in the pond. So our differential equation describing that system is dV/dt equals inflow minus outflow. The inflow is just constant, and the outflow is proportional to the volume. K is a constant. So a very simple little model. There's our differential equation. Well, to solve that for v, we integrate that, and we'd say the v at any time in the future is equal to v at time 0 plus this integral. All right, so that's mathematically what we're doing in this simple simulation, in most simple simulation models. How we do that numerically is we solve it as a sum. We solve the integral as a sum. You don't have to worry about all the details, but basically it's solved as a sum. It looks like that. That's how we numerically integrate. So let's look at this, solving this thing with different time steps. And what I've done here is that's a very simple little, this is a very simple little system. Basically it reaches a steady state. So we have some inflow, we have an outflow, and at some point it reaches a steady state where the inflow matches the outflow. Here's 3 solutions. So the black curve is the analytical solution, because that's a simple thing I can solve analytically. And the colored curves are the solutions with different time steps. And I just want to point out, the time step can make a big difference here, right? And the thing you need to keep in mind is, your time step should be such that the approximation that the flow rates are constant over a time step is a good one. Clearly, that's a very bad assumption for 0.5 day time step. And it's a pretty bad one all the way until you get down to about a 0.1 or 0.03 in this particular model with these particular inputs. So I just want to point that out to you. So how do you go about figuring this out? Well, for simple systems, there's actually rules you can use, but you don't model simple systems. Your systems are quite complex and nonlinear. The bottom line is you just use this rule. If you shorten your time step and get a different answer, then your time step's too large. Just do a little testing once you've built your model and make your cut your time step in half and see if it makes a difference. If it didn't, go with the bigger time step. So it's pretty straightforward, but some of us overlook this, and we end up getting unusual results because our time step is just too large to simulate the dynamics of what's going on in the system. Things are changing extremely rapidly, and we have a really large time step. No numerical model can handle that properly. You need to make your time step smaller. One other problem that comes up a lot, and I won't dive into it much here at all, but I just want to point out that as a general rule, you should never reference the time step in your model. Sometimes there is occasionally there's a good reason to do it. Usually there is not. The time step is a numerical artifact. It shouldn't be in your equations at all. All right? It should not be in your equations. It's very rare that you should reference the time step in your equations. Right? When you reference your time step in equations, it's because you're thinking like a spreadsheet modeler. All right, we've got a fixed time step in a spreadsheet. Okay, I can reference that. GoldSim does not have fixed time steps, and that's what we're going to talk about next. So referencing your time step in your models is usually a bad idea. And we actually have a knowledge base article online. If anybody's interested, send me an email and I'll point you to that kind of discusses this issue in more detail. Next thing, for most people, this isn't a big deal. It's pretty obvious. Should I use elapsed time or calendar time in a GoldSim model? For those of you who are new to GoldSim, in a GoldSim model, I can either say I want to use elapsed time or calendar time. And if it's calendar time, I give dates, and if it's elapsed time, I just have an elapsed time in my model. So which is the correct approach? Well, for most environmental systems, you need to use calendar time because you have some seasonal variability that you have to capture. Rainfall and temperature, and so we need to do that. So that's usually a pretty obvious answer. Obviously, for a long-term environmental model, somebody who's doing a radioactive waste model, for example, that's 10,000 years long, obviously you're not going to use calendar time there. You don't really care about the month when you're modeling something for 10,000 years, and in that case you'd get away with elapsed time. I just want to point out something that people often overlook. In an elapsed time model, Okay, we have units, month, MON, and year, YR. And in fact, GoldSim has these units that are built in called MON and year, month and year. Okay, you need to be very careful when you use these. So if you have a flow rate that's 10 gallons per month, 10 cubic meters per month, that's a very poor unit to use. And the reason is, what is the definition of a month? A unit has to have a fixed definition. A month is equal to 30.4375 days. That's the definition of a month. A year is equal to 365.25 days. That's the definition of a year. So if you use these units, month and year, to define rates, you might get some surprises because they don't change their definition depending on what month you're in. It's a unit that's got one definition. So just keep that in mind. And most of you are aware that regardless of what kind of model you're using, elapsed time or calendar time, you can reference what we call, date-paced run properties, right? So I can come into a GoldSim model and I can reference run properties like what year is it, what month is it, what quarter is it, what week of the year is it, what day of the week is it, and so on. And by the way, you can do that even if you're running an elapsed time model. And the reason you can do that, even with an elapsed time model, there's a start time that you can specify. So GoldSim still knows the date. So you can reference those in either case. Okay, let's move on to understanding something that confuses a lot of people. This is it's a fundamental feature of GoldSim, and it's important that you understand them. And it's this concept of scheduled and unscheduled updates. All right, remember, an update is the same as a time step. So what are we talking about here? This is really critical. When people misunderstand this, this is when you have errors in your model. You say, well, why doesn't the model match the spreadsheet? Things like that. So let's just talk a little bit about scheduled updates. So here's a model I've set up that runs for 50 days and has a 1-day time step. Up here is a little button, and this button says show scheduled updates. I can press that and it'll show me, all right, this is when I'm going to update the model. All right, once every day in this particular case, and there's different reasons that you can update a model. It actually has a little some notes here to say this is why I'm updating the model. But the key thing is a scheduled update is an update of the model that GoldSim knows about before the simulation begins. You've specified, I want updates at these points. You've been very specific about it. The key thing you need to understand is GoldSim also has what we call unscheduled updates. These are updates that GoldSim doesn't know about until something happens. We literally insert them on the fly. All right, and it's an important to understand that GoldSim is doing this. So let's talk a little bit more about these unscheduled updates. Why do we do it? First of all, well, we're doing it in order to more accurately represent the system that we're modeling. All right. What kinds of things cause unscheduled updates? Well, there's a couple specialized things that cause it, and we'll walk through these. So, for example, the one that in a water resources model you'll hit about a lot is a reservoir hitting an upper or lower bound. So let's assume you have a 1-month time step scheduled update. You said, I want to do an update every month. But we hit an upper bound or we hit a lower bound, we run out of water, or we hit some capacity in the reservoir in the middle of a month. What does GoldSim do? It doesn't wait till the end of the month. All right? Well, if you do that, you have an inaccurate result. What it does is at the point it hits that upper or lower bound, it inserts a new time step. That's what it does. All right? If we have a random event, I have an event happens every 15 days randomly. It never doesn't happen exactly on a day. It might happen at 14.7 days, and then it might happen at 40.67 days. We're going to insert a new time step when that event occurs. We also have some specialized triggers, and I'll talk about those in a minute. The thing that sometimes confuses people is that these unscheduled updates are not by default displayed when you're looking at a time history. They're kind of just, we're going to do it, don't worry about it. We're going to calculate the result by inserting a time step, but we're not even going to tell you we inserted a time step. We're just going to do it. We're only reporting the results at the scheduled updates when you told us to, but those results are going to be a little different than if we hadn't inserted the unscheduled updates. The unscheduled updates are going to make the results at the scheduled times more accurate. All right. Now, to really understand unscheduled updates, what you really want to do is be able to display them, and we can't tell GoldSim to display unscheduled updates, and that's what I'm going to do here. And basically, if you go into the advanced time settings in GoldSim, you can essentially just tell GoldSim to include unscheduled updates in your results. So let me show you a few examples of this just so you understand how these unscheduled updates work. So here's the simplest example, and many people are familiar with this. This is a pond hitting an upper bound. All right. So in this particular model, I've got a particular initial volume, an inflow rate, and a capacity. And I will tell you that if you just on the back of an envelope do the calculation, this pond should hit its upper bound at 33.8 days. Well, I've got a one-day time step, all right? So, but it's going to hit its upper bound at 33.8 days. So let's go ahead and run this model, excuse me, and look at the results. So here's what GoldSim is plotting, all right? And so you'll see it's plotting a time step every day because that's what we told it to do, okay? And here's the cumulative overflow. So I'm keeping track of the cumulative overflow. The thing I want you to note in this plot is it really started to overflow at 33.8 days. Okay, so at 34 days we reported a certain amount that's overflowed, but because we, without telling you, inserted a time step at 33.8 days. At 34 days, all you're seeing is 0.2 days of overflow. That's all you're seeing. So that value is correct, okay? That value is correct. We're not showing you that there was another data point in between those two values because the overflow rate really didn't ramp up like that at all. Let's see what really happens. Let's plot all of the time steps now. I'm just going to come in here and tell GoldSim include all the unscheduled updates. Let's actually look at those unscheduled updates. And now if we run the model and we look at the cumulative overflow plot and we look at the volume and the overflow, now you see what really happened. Okay, here you see there's 33.8 days. Sorry, we're inserting a time step right there. And now we're showing you exactly what happened. 33 days, 33.8 days we started to overflow. The results at the scheduled time step are the same as when we had these time steps turned off. All we're doing here is now we're showing what happened in between. You usually don't care what happened in between, but this helps you understand what GoldSim just did. It inserted a time step. I mean, let's look right here. Let's look at the table. Here's my table of time steps. One, go down. It's all one-day time step. Oops, I inserted a new time step at 33.8 days. Now, you'll notice that we don't see another time step till 50. It doesn't mean that GoldSim didn't have any time steps after this point. When you have inserted time steps, you could have a lot of them. So when we actually plot them, we only plot the ones that are different. So in this case, it stayed constant. The value stayed constant at 1,000 all that time period. So we don't actually, in the plot, bother to show that there was a time step at 34, 35, 36 because they're all constant at that time. So there's a simple example in which we have an overflow. Now let's look at another example. Let's just look at an event. And so in this model, all right, I just have a pond that has some water flowing into it, and about every 15 days, roughly every 15 days, okay, I decide to remove 5,000 cubic meters. All right, so that's all I'm doing. I have an event that pulls instantaneously, it's 5,000 cubic meters of water out of this pond. So let's go ahead and run this model and just look at the volume. And so there we are. We're going up, pull out 5,000, going up, pull out 5,000. So the question is, when did that event occur? This says the event occurred at 29 days, and this one says it occurred at 38 days. There's no way that it happened that way. All right? I mean, it was a random event. Let's now turn on our scheduled updates and see what really happened. Well, what really happened is that event occurred at 29.669 days. That event occurred at 38.87 days. We inserted a time step right there. Keep in mind the values at the scheduled updates are exactly the same as when we weren't showing these unscheduled updates. All we're doing is showing another time step in there. But the values at this point are exactly the same as the value I just calculated previously. So when GoldSim doesn't plot the unscheduled updates, it's still using them. All right, they're still in there. You're just not seeing that data point at that point. Again, let's look at the table here. And here you'll see, here's our time steps. 27, 28, 29. Oh, event happened at 29.669 days, 30, 31, 32. We keep on going down. Oops, event happened at 38.87 days. So we're inserting a time step at that point, and then we're going back to the scheduled updates. All right, so that's how these scheduled updates work. Let me show you one other a use of these schedule updates that probably most people aren't aware of, but it's quite powerful. So what we're looking at now is I want to turn a pump on. I have a pump and I want to turn this pump on, and I actually want to turn it on when the volume reaches a very specific value. All right, in fact, I want to turn it on when it equals 10,052 cubic meters. So I have a little status element here, and the status element says when the pond is greater than 1052, this becomes true, okay? And my pumping rate, if the pump is on, my pumping rate is some value, otherwise it's 0. All right, so I want to make this happen at exactly 1052. How do I do that in GoldSim? Well, some of you might say, well, I'll just say on true, pond 1 greater than that number. If you did this, it would not happen at 1052. On true, an on true trigger is checked every scheduled time step. That's how it works. So this would happen at the first scheduled update after pond 1 was greater than 1052. But if you say at stock test, GoldSim's going to do more work now. It's actually going to monitor pond 1 and actually it's going to try to make a prediction of when it reaches that value. And GoldSim will actually insert a time step at that point. All right, so let's go ahead and do that. Let's go ahead and turn on our unscheduled updates, and we'll plot that. And what you'll see happen here is we turn the pump on right there, okay? And in fact, we turn the pump on exactly at 1052. And that happened to happen. We had a one-day time step, 8, 9, up, but that became true at 8.852 days, turn the pump on. At that point, things started going down. So in cases where you really have to catch things exactly, and you don't want to just wait for the next time step, here an at stock test inserts a time step, just like hitting an upper bound inserts a time step, just like an event inserts a time step. So these are 3 cases that you need to be aware of where GoldSim can insert a time step. And what this means is the time step isn't constant necessarily. It can change on the fly in order to more accurately represent the system. Okay, let's move on to the next topic. And this is quite common, and it's particularly common when people are, they find out about these unscheduled updates, and they get a little bit nervous about this. What if I had a monthly time step? Well, wait, you're inserting time steps in the middle of the month, but I need results, at the end of every month. So let's look at an example here. What if you had a one-day time step, but what you wanted to report was the average monthly value, or the average annual value, or the value at the end of every month, or at the value at the end of every year, all right? Or the cumulative amount of a value every month, right? You have a one-day time step, but you really want to report things at a different level. And the way we do that in GoldSim, we use something called reporting periods. So if you look at the simulation settings dialog, here's a model I've built. If you look at the screen, we got a model. We're going to do calendar time. We're going to have, let's say, run it for 91 days and with a daily time step. But what we've done down here, we said, well, in addition to having a daily time step, I want to have what we call reporting periods. And you can have 2 different types of reporting periods. Here I'm going to say I want to have a monthly reporting period. All right, I can have multiple categories of reporting periods if I wanted to. In order for this to work, you need to take 2 steps. The first thing you need to do is first tell GoldSim in the simulation settings dialog, I want to add one or more reporting periods. That's the first step that you need to do. The second step that you need to do, in the result element that you're interested in, you have to tell GoldSim what you want to do with the result. So let me show you an example of this. All right. In this particular model, okay, I've just got basically a flow rate. Don't worry about what it is, but it's a noisy flow rate. It's a daily time step model. I got a daily time step, okay, runs for 2,500 days, and I've got this noisy flow rate. And what you're looking at here is a value every day, all right, every calendar day. All right, so that's what I've got. And that then feeds into a volume, which then kind of does something like that, kind of slowly is moving upward because I have a kind of a noisy input signal. All right, so what I want to do now is look at that input signal in a more intelligent way. So there's my input signal all by itself. That's what I've just shown you. But now I'm interested in knowing what is the average monthly value of that input signal. What's the average monthly flow rate? What's the average annual flow rate? Right? This is the daily flow rate. It's bouncing all over the place. How do I tell GoldSim to plot to me the averages? All right? Because all I've got the daily values. What I need to do is as follows. Okay? We'll go back to edit mode here. What I've done here, okay, in fact, we'll do it from scratch. All right, I've got a result element here. I'm going to say I want to plot the flow rate, which is that guy right there. All right. Because I've set up reporting periods, you'll notice I've set up 2 reporting periods, an annual reporting period and a monthly reporting period. Because I've set up reporting periods, GoldSim's, the result element now looks different. Looks quite different. It lists the result, but now it says, what do you want to plot? What do you want me to calculate? And I'm going to say in this case, it's everything. Just show me all plot points. This is, if I choose all plot points, it's just going to plot every daily value. But now we'll give this a name, daily, because that's really what it is. Now I'm going to add another result. It's the same result, flow rate, but I want this to show me the average. And now I'm going to tell GoldSim I don't want to see all plot points. I want to see the averages. So I've actually told GoldSim, when you plot this, show me the averages. So now I'm going to, on the same plot, I'm going to have all plot points and the averages on the same plot. So now when we run this model and look at this guy, let's change that color just so it pops a little bit more. We'll make this blue and maybe a little thicker. All right. So what you're looking at here is there's my daily values and there's my average. What average is that? Well, that's the annual average. Remember, I had 2 reporting periods. Well, I want to see the monthly averages. There's the monthly averages. All right. So what you're seeing GoldSim is plotting here is the monthly averages. Let's look at the table of results. Now I'm showing the monthly values right here. These are the monthly values, the average monthly value. Okay. That actually is the daily value on the last day of the month. That's not what you want, plotting both of them. That guy right there is the average monthly value. That's the average annual value for 2013, 2014, 2015, and so on. And so you see what we've done here is we've taken this signal and we've post-processed it to calculate these averages. And that may be what you export, that may be what you really plot. You really don't care about the noisy signal. What you really care about is those monthly averages. All right, so the reporting periods provide the ability to do that. There's other things you can do with reporting periods. So if we go here, I've chosen to show the daily flow, and then instead of showing the averages, I say I want to see the value at the end of the period, at the end of the month or the end of the year. So that's what I'm plotting here. So this basically is the average values, and that, what I'm plotting here is once a month I'm plotting the value at the end of the month, the instantaneous value at the end of the month. This is the instantaneous value at the end of the year. Again, may not be all that useful to you, but it's one more thing that you can plot. Here's another thing I can plot. Okay, what I've plotted here now is I say take the flow rate, plot all the data points. Now take the flow rate and calculate the cumulative, the integral over each period. This is going to have different units. Obviously, this is a flow rate. This is going to be a volume. So if we look at that result, all right, that value that you're plotting right there is the cumulative amount of water that flowed in 2013. That's the cumulative amount of water that flowed in 2014. That's the cumulative amount of water that flowed in 2015. I can go down to the monthly values too, right? Annual is a little bit easier to see here, all right? So now we're actually taking this guy in, and as a post-processing step, we're accumulating it. And you can also do something similar. You can actually take the derivative, the rate of change of something, all right? So here I'm looking at the volume. I'm plotting the volume, and now it says show me the rate of change of the volume over each period. So that's the rate of change of the volume over 2013. That's the rate of change of the volume over every month. So what these reporting periods do is they give you the ability to take a signal and then at a small time step and then do some processing at a larger time step. I've got a daily time step, but I really only need to report monthly values, and I want them to be monthly average values, or I want them to be the value at the end of the month, or I want them to be the cumulative value over the month. That's what reporting periods provide for you. They're very, very powerful, a very, very powerful feature that not enough people use, quite frankly. You know, take a look at this. It's described in quite a lot of detail in the manual. It's just a very, very powerful feature. All right, let's move on to the next time stepping, and that is this ability that GoldSim has to do what we call telescoping. So telescoping means I'm going to vary my time step, but I know how it's going to vary. I'm going to specify how it varies before the simulation starts. So we're not being reactive, we're being proactive. We're saying I want the time, this is a very classic thing that's done in very long-term models, like a radioactive waste management model. You might have a 10,000-year simulation. During the first 1,000 years, things are happening very rapidly. There's a lot of dynamics in the first 1,000 years or the first 500 years. All sorts of things are changing very rapidly. In order to capture that, you need a small time step. But at longer time periods, everything is changing very slowly. You don't need that small time step at the longer time periods. So in that case, what we want to do is we want to say, oh, start out with a small time step and then make it bigger. So GoldSim basically provides a capability to do this. So here's an example. I'll show you where this is in the dialog, but it basically says, hey, between 0 and 10 days, I want you to do a 1-day time step. Between 10 days and 20 days, do a 2-day time step. Between 20 days and 40 days, do a 5-day time step. All right, so let's look at a model that does telescoping. It's pretty simple to do. So this is just a leaky pond model, but what I've done down here under advanced features, I've told GoldSim to do what you've just said. I said for the first 10 days use a 1-day time step, but by the way, the default time step is big. It's 10 days. All right, so I have a 10-day time step. All right, I have a 10-day time step and I'm going to go for 100 days. All right, so the default is a 10-day time step. This overrides the default. So it says between 0 and 10 days, use 1 day. Between 10 and 20 days, use 2 days. Between 20 and 40 days, use 5 days. And then by default, after 40 days, it would use the 10-day time step. So we're just kind of telescoping out our time step here. And if you run this model, I've kind of plotted where the time steps are. You can see that. So here, 0 and 1 day, so there's a 1-day time step. 5 days, we're still at a 1-day time step. I guess here we go to a 2-day time step. 10 days, 12 days, 14 days. Now we're at a 2-day time step. 20 days, 25 days. Now we're at a 5-day time step. And then above 40, we're at a 10-day time step. So you can see we've just telescoped out our time step. So that can be a useful feature. It's very simple to do. You know beforehand how you want to control that time step. Okay, now so this is something where you know how the dynamics are going to change, and so you can take action before the simulation starts. In some cases, all right, in some cases, you don't know when you need to shorten the time step. Well, GoldSim actually allows you to do that. It's not often that you need to do this, but you could do it. So for example, you might say, hey, if this event occurs, if there's an accident or if there's an earthquake, I want to use a smaller time step for the next 10 days. Or if a particular variable in my model is between 500 and 600, I want to use a smaller time step. I don't know when it's going to be between 500 and 600, when I build the model, but if it ever is, I need to use a smaller time step. So GoldSim provides this capability, and what you literally do in GoldSim is in a dialog, you specify what the maximum time between updates is. All right. But by default, the maximum time is whatever your default scheduled time step is. But here I've said, hey, if this thing is true, if use small time step is true, I want the time step to be 0.2 days. Otherwise, I want it to be 1 day. So where do we find this information? Well, let's go and look at a model that does this. So here's our dynamic time stepping model. And what we have here is just just a leaky. It's a leaky pond. I've got a 1-day time step in this leaky pond. But if I go into my advanced time step settings, I've said if use small time step, I want it to be reduced to 0.2 days. Otherwise, you can go back up to the default of 1 day. So when is that true? Well, in this particular model, I just did something very simple. I said if the pond volume is between 500 and 600, I want to use a smaller time step. Yeah, in this particular case, there's no real reason to do this, but it's a nice way to illustrate it. So when the pond volume is between 500 and 600, I want to use a small time step. Otherwise, the 1-day time step is fine. So let's go ahead and run this guy. And there it is. Okay, so basically we're using our 1-day time step until, oops, sorry, we're between 500 and 600. I want a really small time step. Now we can go back up to the big time step. And in order to do that, all I needed to do is tell GoldSim right here, here's basically write an equation here. Usually it's going to be an if statement. If this statement is true, that's my time step. And obviously this is smaller than the default time step. Right? By the way, just to let you know, if I had said 10 here, it would have ignored that. All right. My maximum time between updates can never be greater than what my default schedule update was. And my default schedule update, you recall, was 1 day. But it can be smaller. This is really to make things smaller. It says if this is true, ignore the default and use a smaller value. All right? If I made this 10, it would ignore it. It would just use the default. The whole purpose of this is to use a smaller value, not a larger value, because it's the maximum time between updates. All right, so that's using dynamic updates. Another powerful thing. Here's something that is also quite powerful, fairly rare, but I want to go ahead and point it out to you. Sometimes you may need to have a shorter time step in different parts of your model. So imagine you had one part of your model where the dynamics were changing very rapidly. The rest of the model, things were changing slowly. Well, if that's the case, you need a small time step to capture that stuff that's happening in that one part of the model, but you don't want to force that small time step on the entire model. What you'd really like to do is say, let's just force that small time step on one part of the model, and the rest of the model can have a larger time step. And we can do that, and we do that by telling, you basically do it to a container. So a container can have its own time step. And within the container dialog, you basically tell the container that you want the container to have what we call an internal clock. All right, so let's go ahead and look at a model that does that. So this is a model in which what we're doing is I'm solving a very, very simple integral. I'm solving an integral that says, you know, I'm solving this integral. The value is equal to an initial value plus the integral of minus k times the value. All right, very simple. This is how GoldSim would solve that, by the way. There's the integral. Basically, say start with an initial value. It's a minus, which means it's a withdrawal rate. All right, and I'm just going to take that constant, k, and multiply it by the integral, v. So this reservoir solves that integral. So that's all we're doing is solving that integral. It's quite simple. If I were to run this model, there's a solution. It's just an exponential. I can actually solve there's an analytical solution to this, and that's what the analytical solution looks like. All right, so nothing complicated here. But now I want to show that, you know, solving that integral, I can actually get a better solution if I use a smaller time step. So in this case, I've got a 10-second time step. It's a 50-second model. I got 5 time steps. All right. What I've done here is set up a container. Inside the container is the exact same information. It's an integral. It's the exact same integral. The only difference is I've assigned this container to have an internal clock. All right. It says I want this container to have an internal clock. When you give an container and an internal clock, it adds a tab up here, and you say, what do you want the time step to be? I want it to be 1 second. Instead of 10 seconds, I want it to have a 1 second time step. So in this case, what's going to happen, we're going to run this model. Every 10 seconds, we're going to update this guy. Okay? every 10 seconds we're going to walk into this guy, and then we're just going to walk through. In order to update this guy, he's going to zoom in and he's going to take 10 updates to update for 10 seconds. It's going to basically have a one second time step. Let's compare the results. So if I run this model and I plot the analytical solution, this solution is exact same integral, 10 second time step. This solution, 1 second time step. There you see the results. So, you know, the analytical solution is the red curve. We're only plotting the solution every 10 seconds. All right, so ignore the stuff in between. The blue curve is the internal clock. The green curve is when we have a very large time step. So we actually have a very poor result here. We're very close when we have this. So this is a rare thing that you need to do, but occasionally it comes up when part of your model needs a smaller time step. All you need to do is say, give me an internal clock. That's the time step I want to use here. And this obviously has to be a smaller time step than the model time step. If you give it a bigger time step, it's going to ignore it. This is saying, give me a smaller time step than your model time step, and that's the time step I'm going to use only to update this container. Okay, the last thing, or the second to last thing I want to talk about here is creating capture points. So we have this concept of what we call final value results, right? So you want to look at a distribution or a scatter plot or an array plot. We do these things at the end of the simulation. Show me the distribution at the end of the simulation. Sometimes, however, it might be very valuable to plot distributions, for example, in the middle of a simulation, right? And in order to do that, I have to create what I call capture points. All right, so within GoldSim, I can say, by default, I'm going to always capture the final result, but I also want to capture the result of 3 months, 9 months, and 18 months. Okay, well, how do we do this? Well, let's take a look at a simple model that does this. All right, so here's a model. It's just got this model basically has a random history. Just a whole bunch of random histories. All right. What I care, if I just look at a distribution of this, I get a slice right there. Show me the distribution at the end of the simulation. So if I right click here and say show me a distribution result, that's the distribution at the end of the simulation. All right. But I don't want to just see the distribution at the end of the simulation. I'd like to see a distribution right here. And I'd like to see a distribution right here. And I'd like to see a distribution right here. How do I do that? Well, what I do is I tell GoldSim before I run the simulation, save capture points at 3 months, 9 months, and 18 months. Just add these what we call capture points here. And now when I plot that distribution again, there's my distribution, final value. But now there's a little drop list here. And it's going to show those capture points. There's a value at 9 months. There's a distribution at there's the distribution at 3 months. There's a distribution at 9 months. There's a distribution at 18 months. There's a distribution at the end of the simulation. And keep in mind, it spreads out because we're basically looking at a slice here, 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 and here. And there is those slices. I can specify those capture points. Here's another cool application of this. I'll just show you one other simple model. This is a contaminant transport model. I'm just looking at diffusion basically through some cells. And if I were to run this model, I have these 5 cells. I start out with some mass in the first cell and second cell, first cell, and you know, after 3 years, these guys are all pretty much at the same concentration. So I'm just looking at time histories here. But one of the things you can do in GoldSim is I can create an array and then plot an array, and that's what I've done here. I've taken the results and I've created an array. Cell 1, cell 2, cell 3, cell 4, cell 5. I want to look at a snapshot of each one of those guys. I've set up capture points in this model. 0.1, 0.5, 1 year, 2 year. So different times. There's my final value. There's a result of 0.1 year. There's a result of 0.5 years. There's a result at 1 year. There's a result at 2 years. There's a result at the end where they're pretty much all equal. All right, so this is an array plot, right, where I had to create an array, and the array had one item for every cell in this case, but it allowed me to show this pretty cool little progression of over time of what the actual concentrations look like in those 5 cells. Again, pretty simple, but another use for these capture points. Okay, last thing I want to talk about is saving time steps. Even if you define scheduled time steps, they're not necessarily going to be saved, right? You keep in mind when you set up GoldSim, you can say, I have some time steps, but you don't need to save all of them. You may only want to save every 10th one or every 5th one. Otherwise, perhaps the the results will get too large. You'll see that in some cases you might have a daily time step, and you might tell GoldSim, look, I also have reporting periods. I have a one-day time step, but I don't need to ever look at stuff at a daily. I'm only going to look at my reporting periods. So don't save any of the basic steps. Don't need that information. You need to. We're going to do a calculation every day, but I never need to plot it. The only thing I ever need to plot are my monthly values, which I've set up reporting periods to look at. So in some cases, you may say, don't save any basic steps at all. Just save the reporting periods. When you have the telescoping time steps that I showed you before, it's optional whether or not you save them. So when you set up a telescoping time step, so I want to have a 0.1 day time step between 0 and 10 days, I have to tell GoldSim whether or not to include it. I may want to have a small time step, but I really don't need to plot all those values. In that case, I just don't click the box. So the reason we do this, we give you lots of options for what you save, and the reason is otherwise things can get out of control and you can end up with 2 GB result files, right? Nobody's going to look at 2 GB of data, all right, but you saved it all. So we want to always provide a lot of options. Do I really need to save all that information? What can I turn off? Keep in mind that unscheduled updates are not saved by default, and I don't think you should save them by default. Unscheduled updates in general, you're only going to save it just kind of helps you understand what's going on, but in general you don't need to look at those what we call high resolution results. Now one thing that comes up, we have questions from time to time. People say, why can't I see my time history results? I don't see anything. All right, this is something that happened in 2 years ago to help reduce the size of files. We would routinely have people send us a file to debug that was 2 GB. And the reason is they had 1,000 time steps and 1,000 realizations, and they said, oh, I'm saving everything. We don't do that anymore. The rule right now says, since version 11, if you're doing multiple realizations, we are only saving time histories for elements that are hooked up to a time history result element. So the action of creating a time history result element tells you, you're basically telling GoldSim, I care about this result, save its histories. If you don't create a time history result element and you've got multiple realizations, if you right-click on that element, there is no time histories to show. We're not going to save that. And by doing so, we immediately reduce the size of files by at least a factor of 10, usually a factor of 100. Right? Again, the purpose here is files were getting enormous for no reason because people just saved everything. They only really need to look at 10 results, but they've saved 1,000. All right, so that's one of the things you have to keep in mind. If you want to look at a result, multiple realizations. If you only run a single realization, we save everything by default. But if it's multiple realizations, we're only saving time histories for things that are hooked to time history result elements. Also, one thing to keep in mind, if you've got arrays, and those of you who do contaminant transport modeling will have arrays, by default, that saving time histories for an array is checked off. You can check it on, but we check it off by default. This was another thing that was creating enormous models. People might have an array of 1,000 or 100 items, many arrays of 100 items, multiple realizations, multiple time histories, multiple time steps, and the results get enormous. So by default, if it's an array, we actually just leave that box checked off. You can go and check it and say, yeah, I want to save it all, but by default, we're going to check it off. So these are reasons why sometimes you might say, why don't I see time history results? Okay, that's all I have to say. I mean, covered a lot of material. Might be difficult for people to ask questions. What maybe the best way forward at this point is for, if you have questions, send an email. Send an email to support@goldsim.com if you have a question on any of the stuff we just talked about, and we'd be happy to talk more about it and give you more insight. The last thing I'd like to talk about, just want to give you a heads up. Many of you know about this, but in the last couple months we rolled out this new licensing system. For those of you who have standalone licenses, this is a trivial thing. It will take you 5 minutes to change over to the new licensing system. For those of you who have floating licenses, it's a little bit more involved because you probably have to get your IT person involved to set up the new software on the server. But that's going to, we've rolled out maybe a third or so of people are already converted over. That's going to continue to happen. If your license dies for any reason in the next month or so, we're going to say, okay, here, switch over to the new system. So just want to give you a heads up there. If you have any questions on that, again, send an email to support@goldsim.com. Finally, I just want to start to give you a heads up that's way out in the future, basically late summer or fall, but the next version of GoldSim is going to be a big change from the current version. In particular, we've completely rebuilt the graphics engine in GoldSim. So all of the images, all the icons, all of the drawing tools are now using a very modern, instead of 15-year-old rendering system. All the graphics have been redone. Everything it works. It looks great on high-resolution displays. The new version of GoldSim is going to. There's also a number of features too, but the big thing that's going to pop out, the look and feel is completely different because all of a sudden we've jumped 15 years into the future and got a very powerful graphics engine. In summer, we'll probably be looking for people to beta test that. If you're interested in that, again, drop us an email and we'll put you on the list. And once we get a version that can be beta tested, we'll pop it out to you and let you play around with it. And that would help us quite a bit because we'd appreciate your input. Okay, well, thanks for your attention. And as I said, if you have any questions on any things I talked about today, send us an email, and we'd be happy to get back to you and discuss it further. All right, thanks a lot.